Wow, welcome everybody. Hey, time to wake up. Okay, it's afternoon. Okay, you got to get pumped up. All right, you pumped up? Okay, that says pretty weak, dude. That is pretty weak. All right, so hey, my name is Ron Jacobs, and I am delighted to be here today to talk to you about this very obscure and opaque title. So today we're going to talk about how do I design and deliver on scalable and resilient, okay? And this is going to be an interesting challenge here. I've been kind of frantically up here running my demo, which I'm serious, was like working about 15 minutes ago when I left my hotel room and walked over here and is suddenly kind of freaking out. There it worked. Okay, good. Whew, we're in good shape because I'm telling you it would be kind of ugly if that didn't work. All right, so let's think about this. Because look, we all want to have scalable, right? I mean, scalable is the word everybody shoots for, everybody loves. But honestly, I have to tell you that before I get into that, I want to tell you what the agenda for today is. We're going to look at the problem of scalability. And there's an essential problem that we have to deal with. There's a tension that we have to overcome. And so I want to think about the problem, and then I'm going to present to you a possible solution. It's not the only solution. Might not be the right solution or the best solution. It is a possible solution. You'll have to decide if it's a solution that makes sense for you. And the good thing is, if you adopt this solution, you'll come up with kind of new possibilities of things you could do because this solution's in place, and we'll consider some of those. And then if you said, that solution is something I want to investigate further, I'm going to tell you what you can do next. All right, so that's the plan. Now, how many of you have heard this phrase before? Do the simplest thing that will possibly work. Anybody heard that? Yeah, okay, if you're like an agile person, that's like your mantra. Somebody showed you some complicated, huge thing, you just like, get that out of my face, I want simple. And honestly, I think it was Kent Beck that said this. I think this makes so much sense, right? I mean, when you start with complicated, you're already in trouble, don't you think? I mean, it's like, come on, can't we do something simple here, something that will work? And there's a level at which simple doesn't work. Okay, we know that. But honestly, most of the things that we build, we just have no idea how big they're going to get. And truthfully, most of them won't get that big. I know you'd like to think that your site is the next Twitter or Facebook or something like that, but truthfully, most things won't get that big. So this phrase makes all the sense in the world. You should start with the simplest thing that should possibly work, and then you know that you can always refactor later, you can always kind of move along later, and so you have this statement which makes a lot of sense. But then there's the issue of scalability. And it's funny because we toss around this word so much that sometimes I think we forget its meaning. So I was in a conversation with somebody the other day, and they were going, scalable, it has to be scalable. And I'm thinking, what do you mean by scalable? Because what they were saying didn't make sense to me. So I thought, thanks to our friends at Wiktionary, we can have a good definition here. Scalable simply means that your system is able to support the required quality of service as the load increases. Okay, so load increases. Your site doesn't suck. That's what we want. No suckage, okay? We want to meet the required quality of service, okay? And so, but do you see there's a tension here? That this is a great goal, but often simple doesn't do that. It just doesn't. Now, when we look at what a lot of people build, and when they start with simple, this is very typical of what we see people build. So because they want simple, they use session state to store things. And because they're using session state heavily, they want to use sticky sessions on their front-end router because, they want to route to the same server. Okay, that's cool. And, if your site is small and it doesn't get a lot of traffic, who cares? It's probably going to work fine. And so then on the web tier, each machine is going off and is kind of getting data from the database and round-tripping and doing its thing. And it's okay that the data, if you do cache it, it's only in one of the stores. That's totally fine for most, that's fine for simple. But then on the data side, your database can get a little saturated. Sometimes CPU, sometimes network. Sometimes it's, and if you're accessing web services, the experience can be a little slow. But if you only have 50 users, who cares, right? It's not going to matter. Do the simple thing, okay? And if that's what you aspire to, good. You are there, all right? But if you want to take your site, kind of beyond to the next level, what can happen often on the web, and it's almost unpredictable, when people like your thing and they start tweeting at all their friends, and pretty soon, next thing you know, just the whole thing blows up. And all kinds of traffic happens, and your servers are crashing, and your services are slow, and the database is hot, and now you're faced with the problem that you bet on simple, but it's not very scalable. Okay, this is a bad place to end up, and when you get there, what you hope for is that you're not in a place where you have to rip it all apart and start over, or re-architect from the ground up because you made some really bad decisions. So let's amend our thinking a little bit. Let's say that if we start at the beginning, remember we said, do the simplest thing that will possibly work. See, that's the key part. That will possibly work. So we have to think through a little bit of some of the scalability issues that we get to. Now, I mentioned that we're going to have a possible solution. So are you ready? Here it is. Here's the possible solution. One of the key things you can do is to keep your data near where you're going to process it. I mean, this is a great idea, right? It's been around forever, right? It's called a cache. And it's funny when you think about cache, we are so used to the computer science term, but if you read about explorers like who go to the South Pole or something, what do? They know they can't carry all the food they need, so they go drop some food somewhere along the way, have a helicopter drop it or whatever, and they might hide it or whatever, and then when they get there, the food is there. It's kind of like the data is near the processing, right? So you kind of keep it near, and that makes all the sense in the world. And in fact, caching is a very good idea. It was baked into the fiber of the internet, so you get caches all over the place, right? And in fact, it's just a good idea. I think that's a no-brainer. You're like, I came here for that? Oh, great. All right, so this is good. This is good. But it's limited, right? And that your cache is scoped to a particular machine and a particular process on that machine, right? Because it's memory that just lives in some process. And we got process isolation, and so it's kind of scoped there. And of course, machines die or they get rebooted or whatever. Your processes recycle from time to time. Things like that happen. And really, you have this limiting factor that there's only so much memory on the machine, right? And so you have this trade-off, like how much memory for the cache and how much do I allow for processor and web pages and things that I need. And if you get that balance wrong, it's sort of a mess. And so your memory is a limited resource, and you have to try to balance it out. So as a result, we do some caching, but not that much, probably because we're worried about the memory utilization. So the team back in Redmond said, well, what if we could change this? What if you said you can have as much cache memory as you want and are willing to pay for? Okay, as much as you want. 5 gigs, 10 gigs, 100 gigs of cache memory. What if you could? Well, I think that would be fantastic, right? And what if you could take this giant cache and share it across servers, services, and clients? That would be pretty darn amazing. I think it would open up entirely new possibilities and ways to solve problems of scalability. And in fact, what if this platform was something you could get for free? You notice there is a small little footnote there that we don't know yet exactly because they're still trying to work this out. But some of the higher end features might only appear in certain editions of Windows Server. Okay, so that's the caveat. We don't know exactly what that's going to be, but anyway, free. You love that. I love that. Okay. So this is is part of what we call Windows Server App Fabric. All right, it's the caching part. Windows Server App Fabric is something we announced at the PDC in the fall. We shipped Beta 1. Actually, about 2 weeks ago, we shipped Beta 2 of App Fabric. And so App Fabric kind of has pieces for hosting services and workflows and for doing great monitoring and stuff. We're not going to talk about any of that today. We're going to specifically focus on how does this caching thing help us with building our web services. Some of you might know it by its code name, which is Velocity. and you might have heard of it under that name, but that's the thing that we're going to mostly talk about today. And so what is it? Well, it's an explicit, distributed, in-memory application cache for all kinds of data. All right, so that just simply means I get a bunch of servers. I can start with one. I can grow it up to n number of servers, and they start talking to each other, and they distribute data amongst all the servers in this cache layer. And when we use the term fabric, this is really the fabric-y part of App Fabric. All right? Now, have you ever had one of those ACE bandages, you know, like you sprained your ankle or something, you got the ACE bandage, you know what I'm talking about? Those stretchy bandages you wrap around your injury, right? Think about a fabric, like one of those. What's cool about it is maybe it just sits there like this, but then you could stretch it, it grows, 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 it gets as big as you need, and then you kind of let it go and it comes back, right? That's the notion of a fabric. And in fact, in Windows Azure, there's a lot of code that implements a fabric where we get a bunch of servers that talk to each other and they know about each other. You never see this if you're writing apps for Windows Azure, but it just happens. It's how Windows Azure kind of dynamically grows to the things that you need. Well, what we did is we took some of that Windows Azure fabric-y code and we put it into Windows Server App Fabric, and this is the first little bit of that code that's going to end up there. Over time, more will. So what I have is this cluster of servers that can kind of grow and stretch. So if I say, well, today I have 2 cache servers, but tomorrow I want 5, I throw a couple more on there. I don't have to reboot things. I don't have to restart stuff. I just throw them on there, then they suddenly learn about each other, and they just kind of expand out and use it, which is pretty cool. Now, to the clients, this looks like one giant cache. They don't know that there's 5 servers, 10 servers, 2 servers. They don't know. All they know is that there's a cache, and it can get data out of it, which is cool. That's what I want. And then the caching clients can be anything. It could be an ASP.NET website. It could be a smart client app of some kind, console app, a Windows service. Somebody asked me, can you call into the cache from browser-based code like JavaScript in the browser? No, you can't really, but you could. You could call back to the server and have the server get the stuff out of the cache for you. You could do that. So I guess that kind of counts, right? So that's essentially what it is. Now, if we think about what does our web architecture look like with caching, we kind of went from 3 tiers to a 4th tier. We now have a caching tier. So the way this works now is that because we've got a cache tier, we don't need sticky sessions anymore. Right? Now our session state's available to any web server, just it doesn't matter which one you go to. That's a big win. I like that right there. And then, of course, on the web servers, if we cache something, it's not just cached in one of the servers, it's cached in all of them. And so that's great. On my cache tier, if I say, well, how much cache memory do I want? I get as much as I'm willing to pay for. Right? I can, throw another server on the rack. I mean, I got another, 4 gigs, 8 gigs, 20, 30, 100 gigs, whatever I want. So I can get lots and lots of cache memory. And then on the data tier, see, what I can do now is we know that most apps do a lot of reads. And the vast majority of stuff we're doing with the database is read, 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 read. Right? So what if we could just take some of that load off the database, and we could let it focus on what it's doing, what it has to do really well, which is the writes, and we could kind of offload the reads onto these things, or even maybe web services that we're calling, lots of calls on the back end, and so we want to reduce the load on those so we can cache stuff, so we can reduce the load on our data tier and really kind of scale our system up more. All right, so just to kind of give you a feel for how this works, when a client accesses the web tier and they go for some data, we have some requests for keys, right? These are key value pairs, right? So I have a bunch of keys here that I'm going to put into the cache. When I put them into the cache, there is a client library that runs in my ASP.NET process, and it's just going to distribute these keys amongst the servers in the cache in whatever fashion it decides to do it. I mean, kind of, there's no assumption that you can understand the way it chose to do this. It's just going to do it, right? Now, the cool thing about this is it scales in 2 ways. One is, of course, I already mentioned, you can have as much cache memory as you want. You just add more machines, so you get more memory to the cache. Now, somebody said to me, well, Ron, can't we just put more memory on our web server? Well, yeah, of course you could, right? I mean, imagine your web server. What if you put 100 gigs of memory on your web server, and you just said, I'm going to have like 100 gig cache, or well, 80 gig cache on my web server, right? Well, think about this. How long does it take to search 80 gigs of cache? That's going to take a while, right? I mean, it's going to be slow, and the bigger this stuff gets, I mean, your cache implementation is not a database. It's not meant to scale to huge sizes, right? Not to mention, when the garbage collector kicks in on an 80 gig memory chunk, it's going to take a while, right? That would be a bad idea. It honestly would be a bad idea. So what I can do by this, I can put 4 gigs on a bunch of machines. 4 gigs on 10 machines, I got 40 gigs of memory. Now I got more throughput on my cache because I got more processors that deal with more manageable chunks of size of cache. See what I'm saying? So it scales that way. Now, here's some tests that we did in the labs back in Redmond. And so you see here I have a little chart. We got a little crazy warm-up period that goes on over here, but about in here is where it takes off. So you see this red line is the load that we're putting on the server. It's kind of ramping up. And as it ramps up at the beginning, you see this green line, which is our throughput. At first, it starts following the load. It's handling the load. This is good. This is good. And then we reach a point where the throughput flattens out because it can't handle the increased load. It's not going to get any better. So what happens, as the load keeps building, our latency goes up. That means each request is taking longer and longer. And we are rapidly approaching this sucks, right about here. This is where it sucks because the load, we've maxed out the load, our latency is bad, our throughput's not getting any better. All right? Now, this was a test that we did with just one cache server. Now, watch what happens when I throw a second cache server on the cluster. Bam! It takes just a second or so for the cluster to become aware the other server's there. It starts redistributing load. And now, look, our throughput almost doubled. It shot way up under the same load, right? And our latency went down. Goodness, this is goodness. Suckage has been eliminated, for some point. And then we added a third server just to see what happens. We get even more throughput, even less latency. It wasn't a lot more throughput because we already maxed out the network, so we couldn't push any more load on it. But you see, this is darn cool, right? And so this is a great capability for handling some load. Now you say, oh, okay, great, Ron, but that's in a lab. Come on. What about the real world? Okay, well, Associated Press is one of our early adopter customers we've been working with, and they have this site that serves up news and media and metadata about their articles to lots of other sites. They serve 16 million hits a day, and they were using the system web cache before, but that's limited resource. So they figured they were able to increase the amount of data they cache by 6 times, and they're hugely happy with the increased throughput they're getting. By pushing this much stuff into the cache, it lightens the load on the back end significantly. So they're just one of many customers that we've had that are super happy with how this is working for them. Now, let's talk about simple. Let's rewind in our mind. When you're using system web cache, you've probably all done this. It's darn simple. I don't need to review this code with you, but I will. All right. So you just see when I want to get some data from the cache, I go off and say context, current cache, some key, and I get a value, right? If I didn't get the value, it's a cache miss. And so now I go off to my repository, a database or web service or something, and I get the value, and then I put it in the cache, right? All with me? That's easy. It's not rocket science, right? Okay. Now, if I switch to using App Fabric, there's 2 additional things I got to do. One is I'm going to have to new up a data cache factory. This is a class that knows how to create the data cache objects. So it reads the config, and it's going to establish some connections. It has kind of an expensive construction, so you want to construct it once and kind of hold on to these. And then when you need to access the cache, you just new up, you take your cache factory and you get a cache. Now, because we have this humongous cache, we give you the ability to name different caches within the gigantic cache tier. And each cache by name can have different properties about it, in terms of its expiration or its high availability requirements or whatever. So you have different caches that you can have there. And then after that, the rest of the code is exactly the same. That's pretty cool, right? It's not bad, right? So then I don't have to go off and kind of learn some whole new funky other API or anything like that. It is exactly the same as system web cache. for doing kind of simple stuff. Now I'm going to show you some APIs later that are a little different because they're more powerful, but this is the easiest possible thing to do. Now, let's think about what it takes to put this in place. So first thing you have to do is get some servers for your cache. Then what you want to do is install Windows Server App Fabric on those servers. And when you do, it will add a caching service to those servers. And then you have to configure App Fabric. Now, all of the servers have to point to a shared configuration store. This can be a database, or it can be just a shared folder with an XML file in it. Okay, either way, we have providers for either one, and it's a pluggable provider architecture. So if you say, well, I'd like to store the config in some other way, great, write a provider, you can plug it in, store it in some other thing if you want to. All right, so then there's some client DLLs that you will have to distribute. At this point, we don't have like a client install. None of this ships in the .NET Framework itself. So these assemblies are separate from .NET Framework. So you have to go and drop them in your bin directory or whatever you want to do. Then you have to update your web config or whatever your app config, whatever you're using, with the particular configuration. The most important part here is that it needs to know the name of one of the cache hosts and the port that it's going to access. And it doesn't matter which host because they're a fabric, so it doesn't matter. Just as long as it talks to one of them, that's all it needs to know. And there's some other options you can set I'll cover with you later. Now, here's the cool thing, because people have said, like, oh, Ron, this is cool, but I can't move to .NET 4 yet. It's no problem. On your client app, you can use .NET 3.5 SP1 or .NET 4. So in your web app, it could be .NET 3.5. The servers are going to be .NET 4. Okay, so those have to be .NET 4, but the clients do not. Okay. So using this is the same kind of pattern as you're used to with the web cache. It's a cache aside pattern. So the idea is first you check to see if it's in the cache. If it's not, then you go to the database or whatever and you get it and you put it in the cache and you return it. Okay. This cache doesn't know anything about your database. It doesn't know where your data comes from. It's not going to try to figure out if somebody updated the database and try to update it. It has nothing to do with your database. Okay. It's an explicit cache. Now, you can administer this thing with PowerShell commandlets, which are very cool. And so there's a bunch of commands for managing the cluster and monitoring it, as well as, I forgot to put on the slides here, but perfmon counters, so you can see how the thing is doing, how many hits versus misses, and that sort of stuff. So, given that, let's fire over here to my demo machine. Okay, and just take a look here. All right, so I've got my PowerShell, I love PowerShell, command thing open here. It's a command thing. All right, so if I want to see what cache commands, I can just type get cache help. There's a ton of commands here that you can use to manage the cluster. And so, in fact, I was just, like I said, I was just testing this right before I started. So let me stop things, and we'll stop the cache cluster. All right. And so, I can say, get cache host, and, cache host. Okay, so it shows me there I've got a host, and it's, if I have a bunch of machines in the cluster, it will show me all of the machines in the cluster and kind of what their status is. And so, I can see what's going on here. And then I can say, well, all right, let's fire this thing up. So I'm going to start the cache cluster. All right, so it's going to go through all the hosts in the cluster and start them up. And, okay, get cache host. There it is. Okay, so we can see that my service is up. All right, so it's running on my machine. Now let's just take a look at this app here. I've got kind of a simple app. It's got a Blue Yonder Airlines database in it just so I can get the list of airports. Okay, and so let's take a look at this little bit of code here. We'll make this bigger. All right, so here's a page. It has no caching at all, right? We're just going to fire in. We go off and get the context from the using Entity Framework here, and we bind it to a couple of drop-down lists. And so this is no big deal. Let's fire this thing up. Okay, and just so we see kind of where we're at, here's our airport list, and first hit is going to be a little slow. Let's hit it a few times, and we'll see kind of where it lands. So you see we're getting, 10, 15, 17, 14, right in there, 10, 15, I'd say about an average of 13 or so milliseconds for accessing this. And, this is all local, so it's not bad, right? We're just using a local database and just kind of firing up and loading these lists. Okay, that's not bad. Now, let's take a look at what happens if we use the web cache. So I'm going to show you the App Fabric cache version. Okay, let's make this full screen and get rid of these guys so we can zoom in a little bit. All right, so you see here, at the top, I knew up a cache factory, right? And then I went and just got the default cache. There's always a default one. You can create caches with different names if you want. And then I just go and say, all right, well, let me get the list of airports as an IEnumerable of airport. If I didn't get it, so I got null, I just knew up my entities. I get the airports and I call toList because anything I store in the cache has to be serializable, right? So I'm going to have to invoke the query to get the serializable list. And then I put it in the cache. And then I'm just going to do this little put a thing in the item so I can tell where the data came from the database or from the cache, right? So if I got it out of the cache, I'll just say that the data came from the cache, right? And then other than that, the rest of this is pretty much the same. Just bind it to the data. Okay, so let's, no, not that. This one. All right, so if I go here, all right, so that one, first one was slow, but now you can see, we're going to get in 8, 9 millisecond range. So, we're getting a little faster. It's not hugely faster because I'm on a local machine and, not putting it under a tremendous strain. But it is faster, and it's right in line with what I would get if I was using the system web cache with ASP.NET. So, I know that's not like you're going, that's it? Yeah, that's it. That's it, because this was simple. And that's really the goal, right? I don't want this to be rocket science. I want it to be easy. And that was pretty darn easy, just to use this thing and fire it up, and now I can take advantage of it. So I don't have to go and take a 3-day class on how to use App Fabric Cache or something, right? I mean, it's darn easy. All right, so let's flip back over to the PowerPoint. I'm going to show you a couple other things on the demo machine in a minute. One of the cool things about this, and let me just fire this thing up while I am... Read the slide. I'm just going to fire this up while you're reading the slide. All right. One of the cool things about PowerShell is that you can, anything that's in the PowerShell, you can invoke it right from your code. Okay, which is totally cool because one of the things that's amazing, I love it, is when people create tools, create good tools. And let's just be honest, okay? Sometimes the teams at Microsoft build kind of cool technology that's fronted by a lousy tool. Okay, I'm just being honest with you. I mean, that's just the way it is. Sometimes we build no tool or a lousy tool. Anyway, in this case, they went for just PowerShell and let somebody else build the tool. So what happened is there's already a guy in Israel who's a pretty slick developer, and he went and built a tool. And I just got an email from him, like, I don't know, 3 or 4 days ago, and he's like, hey, I built this tool. You want to check it out? And so I checked it out. I go, dang, that is cool. I'm going to have to show that at MIX. So here it is. This is the MDC admin tool. And he built a nice little WPF app. And what it does is it just uses the PowerShell commands, and it just fires through and finds the host and the cache, and it understands things. And, it allows me to add new caches or regions or whatever. It's a little frail right now because he just got started on it, but still, it's a good start, and it's darn cool. It's an exciting little project that he's doing. He's talking already like, no, maybe I should make this Silverlight, and so I said, look, just finish what you got first, okay? then we'll go make it fancy. But anyway, it is darn cool. So I just thought I would show you that. All right, so if you want to play around with it or get involved, the URI is there, mdcadmintool.codeplex.com. So pretty cool little tool that he's built. All right, I know what you're thinking. what about security, Ron? Because this is a security issue, right? We're putting all this data out in our cache, and we got to be careful about it. Okay, so we have totally security, because all the communication that's going on here between the client libraries and App Fabric is simply WCF. And it's using TCP binding. It can have transport security, it can have message security, and so we have options here where you can say what accounts, either domain accounts, local accounts, or machine accounts that you want to work with. By the way, just a note that in a workgroup configuration, if you go home and try this on a workgroup, you're going to have problems, okay? Because the security in beta 2, we're going to fix that for the release, but in beta 2, you're going to have issues with the workgroup. But if you say, look, I don't need security because we've got IPsec or VLANs or something else, you can turn off the security and, to improve the performance a little bit. Now, because this is a gigantic cache, we have a containment hierarchy, all right? You don't have to know this to use it. It's just if you want to get in a little more depth about how this thing works, you might understand this. So each machine has a cache host running on it, which is a service. And the service has its chunk of memory that has named caches. Now, the named caches can span lots of machines, okay, but within the caches, there are regions. And the regions are something you don't have to do if you don't want to. The App Fabric cache will create regions implicitly for you for certain reasons if it wants to, or you can be very explicit about regions. Now, a region is just a way of saying, I have some data that I want to group as a unit and access it together, maybe delete it together. And so, Xbox Live, for example, uses App Fabric cache. And they use the regions, and MSN is also using it for profiles. So, when they log out and they just want to delete all your stuff, they delete a region. And all the keys within the region go out. So it's just a kind of a convenience for you. And then the cache items themselves are stored in the region. They have a key, and the particular payload of the object, whatever it is, has to be a serializable object. It also has some tags, I'll cover that in a minute, and some things like the time to live, the timestamp, and a version identifier, which I'll cover what that's for also. So I mentioned the API, just to review with you here. You create the factory, you get the cache, and then we have simple kind of get and puts. Earlier I was showing you using the indexer, but you can use explicit methods like get and put. And then we also support kind of region-based get and puts. So if you want to use regions, you create a region, and then when you call the get and put, you use the overload that accepts the region identifier as part of the call. Right? And that way you can put things into a region. Now, the other thing that people wanted is that, right away when you do this, people go, oh, this is cool, so I can put stuff in the cache and then I can query the cache to find stuff. No, the cache is not a database. You can't just query it. It's not a database. It's got keys. You have to know the key you want and access the key. And then people said, well, yeah, but we want to do some kind of query thing, so they came up with a way to do tags. Now, the idea might be, let's say we had a toy website where we sell toys, and we want to have on the home page like our hottest selling items right on the home page. And we want all the servers to know what the hottest selling items are. Maybe what we do is we tag certain items in the cache and say, this is on the hot item list. And then you can go and say, okay, get matching tags for the hot items. And it'll return you a list of keys that are in the hot item tag, okay? That's the only kind of querying capability we have here. But it is at least something, okay, just so you can see how that works. All right. Now, the real challenge about caching. Somebody might go away from this and say, dang, this is cool, dude, we're going to get like 100 gigs of cache. We're going to cache everything all the time. That's a bad plan. This is a bad plan. You need to think this through. Because of the cache aside pattern, cache misses are expensive, right? Because if I go, is it in the cache? I already made a remote call to find out it's not in the cache. Now I got to make another remote call to get it, and then make another remote call to put it. So I got 3 remote calls every time I get a miss, get, put, that's expensive, right? What if you would come back to me and say like, Ron, this made my website slower. which it would. It could hurt you more than it helps you if you don't know what you're after, right? So we think of data in sort of buckets or categories of data, some which are better to cache than others, and even this is no guarantee. It's really up to you to understand the nature of your data and how often it's accessed and if it's useful to cache it. The first category on the left there is reference data. This is things like catalogs, lists of stuff that changes pretty rarely. Once a day, once a week or month or something, there's a change to this kind of list. It's usually read-only in terms of the site or services, and this is pretty safe to cache. Typically, you can copy this stuff around, cache it for long periods of time, and it's up to you to think through how long it's safe to cache it. And usually, you're probably thinking, well, who cares if this server has got a fresher version of the catalog than this one for a minute or 5 minutes. I mean, who cares, right? That's fine. It's not going to kill us. So that's one category of data. The next category of data is what we call activity data. And the classic example of that is the shopping cart. So if I have my grocery website and I got a shopping cart, you got a shopping cart, they got a shopping cart, it's read-write data, but it's not shared. It's per user state. Okay? So we have features for that. And then the last kind of data is like resource data. This is read-write data, but it's shared. So it's something like the inventory. The number of cans of soup on aisle 3 is inventory. And if you buy a can of soup and you buy the last one, and I go to the site and it says, the cache says there's still one, but it doesn't know that you bought the last one, that's bad, right? So read-write resource data is trickier to deal with. And then I would argue there's a fourth category of data, which is stuff you should never cache. Never, ever, ever. Like bank account. You don't want to cache that. Like if I go to my bank's website and I go, gee, my checking balance looks a little low today. I better transfer some money out of savings. So I go transfer, I hit the account page and the transfer's not there. I'm going to freak out. Okay, I'm going to hurt somebody. Okay, because I don't want to see a cached version of that page. Okay, there's things like that in the world you don't want to cache. You know what they are better than I do, but think about the use cases. How tolerant is the data of being stale? Okay, and think that through. And you have a lot of control over this. You can say, like, this thing can be cached for 5 seconds, a minute, 5 minutes, 5 days, whatever. You pick the number, and you can go with it. Now, when it comes to reference data, like this catalog, it doesn't change very often. And if you think about it, if we turn off that local, so when I was showing you earlier the cache demo, I was using the local cache. Now you see on the application on the right, there's a local cache. What that means is we're going to use a cache in memory of the process, the local process, just like the system web cache does, which is why if I showed you the system web cache, you would see the exact same numbers. Okay. So the way this works is when the client goes off to get some key, we're getting key 2 here, we ask the client library, please get me key 2. We don't know what server key 2 lives on, but the client has a routing table. And it either knows or it will find out where key 2 lives, and then it will go off and get key 2 from one of the cache servers. Okay? When it gets it, it's going to copy it back onto the client and store a copy of it in the local cache. Now, the local cache is constrained, so it can't store everything. It's going to evict things from there, but it's going to store the most recently accessed things. And so the next time I go to get key 2, we're going to be able to short-circuit that call right out of the local cache. This is an order of magnitude faster than going to the remote machine. So it's really cool to turn on the local cache, and it's pretty valuable. All right, so now if somebody else updates key 2 with a new value, then I've got a problem. Because now the distributed cache has a new value, but my local cache has the old value. Okay, how bad is that? Well, it depends on the nature of the data and how tolerant it is of staleness. You could say, who cares? I'm going to leave it until it expires anyway, and we'll just get it the next time around. There is a feature which says I could ask the client library to register for notifications so that when somebody does update the server, AppFabric will automatically update the copy in my client, in my local cache. I could totally do that. And it's a polling interval that it will spring up and poll occasionally and find out if there's been updates to it. If I want, I could do that. I still run the risk that I might get a case where I still got the old value. Okay, but that's another option for you. Okay. The other thing that you realize right away is that now we're making a remote call. Sometimes the values, the things we're getting are really small, 50, 100 bytes, right? And we go off machine to get it, and then we're like, well, actually, we need 500 of those. And so we're going, remote, 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 500 times. We're back to sucks. That sucks, okay? So this is a reason I might want to use regions, because if I create a region, I say, I'm going to keep all 500 of those things together, and then I can use a bulk fetch API, like bulk get, and say, get me all of these keys in one shot, okay? And one bigger message is better than 500 little ones, right? So this is going to be much better in terms of performance. All right, now, back to simple. One of the things we really wanted to support is people go, well, this looks really cool, but I don't want to have to go and rewrite my app to use AppFabric Cache. How can I take advantage of this? Well, what we did is we integrated this as a session state provider with ASP.NET. So if you've got code that uses session, guess what? All you got to do is configure the AppFabric caching store provider, and then the session state will be stored in AppFabric, and you don't need any more sticky sessions because now your session state will be available to any of the servers in the farm. And you can store your session, you can scale that store dynamically. But then you say, yeah, but what happens if we lose a server? That would suck, because then we lost my shopping cart. So we have the high availability mode. Okay, so let me explain high availability for you. Oh yeah, and you can also, because you're doing this, you can also share session state amongst multiple web apps, which is a little weird, but you can do it if you want to. All right, so let me explain the high availability. First of all, let me say something about availability. Like if you say, this is data we must never lose, we'd say, use a database and a transaction and write that sucker. And even then, the data center might blow up. So use log shipping and get another data center and 500 miles away and ship logs over there. And, availability, you get what you pay for, right? And what did I say this cost? Free. Okay. All right, just want to be sure. All right, so this is not transactional database durability. It is not that. It is also not no durability, no availability, like, my process recycled, I lost everything. It's not that. It's somewhere in between, okay? See, like their server just blew up over there. So you just never know what's going to happen. All right. So this is somewhere in between. You get to decide exactly where that is for you, okay? But here's how it works. So if I have an application, it goes off and puts a value in the cache somewhere. So it calls into the client. The routing table decides, okay, well, this key is going to go on cache 2. So we drop a value into cache 2. It gets stored there, and then there's a replication agent running because this cache is configured for high availability. And the agent recruits other nodes in the cache tier. I'm only showing one, but it's usually more than one. And it will recruit other nodes to store a backup copy of this data. Okay? And this happens very quickly, but it's not covered under a transaction or anything like that. So, things can go wrong. All right, so now, when I come off to get this value, what if cache 2 blows up? Well, cache 1 now decided, I'm going to promote this from the secondary to the primary region. Cache 1 creates a copy and recruits another server to become the backup, right? And then it updates the routing tables on the clients, so then when the app goes off to get it, it knows to get it from cache 1. Okay? That's all it is. Things can still go wrong. You can still lose things, but, this is way faster than a database, but it's not as durable, okay? So you can take your call on that one. All right. Now, let's get to resource data. Remember I said resource data is like the inventory and read-write, and it's shared read-write data. So if we got read-write data, and we say, like, okay, we're going to update the inventory, we're going to write that change to the database. We might also want to update the key, the cache value. Now, this is not covered under a distributed transaction or anything like that. It's not what we're doing here. But there is a little bit of kind of simple locking semantic. Okay, so when you call get cache item, you get a version of the object. And remember I said the object has a version identifier with it. And so every time you update an object, we tweak the version identifier, we update it. And then whenever you put or remove, you supply the version that you're interested in. So this gives us an optimistic locking capability. And the put or remove only succeeds if it's on the version you expected. So here's an example. I have two clients going on, different clients, right? So they both go off and get an item. They get the same item. Okay, and then both of them update the item. And now I've got a race. Who's going to succeed, right? So one of them succeeds in putting the item. When it does, the version identifier is incremented. The second one tries to put, but it fails. Okay, so that's how we did the optimistic lock. It's pretty simple. All right. Now you could say, well, okay, but I'm more pessimistic. I see the glass is half empty. So, I want to do the pessimistic lock. All right, here's how that works. We have an API called get and lock. Okay, and so we're going to get, and the first guy that gets it gets the lock handle, and you provide a timeout, so you're going to lose your lock after a while. And then if somebody else tries to call get and lock, this is going to fail because somebody else has the lock. A third person could call get, that's going to succeed because the get succeeds, it's not trying to lock it, so it's okay. Now, you can also take a lock on a non-existent key. At first, you're going to go like, that makes no sense at all. Let me explain why taking a lock on a non-existent key is a very cool feature. And it was added because some of our early adopter customers asked for it. All right, so I worked with one of our early adopters in a lab, and we had this exact situation. They had a composite web app. Okay, by composite, I mean kind of like SharePoint, like web parts, and the idea is you have all these little parts, and the user gets to assemble the parts they want on the page they want, right? You've all seen apps like this. And one of the challenges of that is that the parts are independent, but they might be doing exactly the same service calls. In fact, what they found when they looked at a lot of their installations, they found that many of the parts were calling the exact same web service. And so they would load a page and get like 3 calls to the same web service with the same parameters and everything. And they go, well, that sucks. That makes our page load slower. It puts all this load on the back end that we don't need. Is there a way that we can, coordinate these calls? And what they didn't want to do is introduce some kind of dependency at the frame layer that required that mediated this. They didn't want to do that. So we came up with a solution to deal with the data race. So here I have 3 things that could be 3 parts, or they could be 3 different pages on the same server, 3 different servers, whatever. I got a bunch of things that are trying to access the same exact values and the same exact data. So what I do is I say, why don't you try to lock the key? Now, nobody has put this data in here yet. It doesn't even exist in the cache. But I'm going to have all 3 of them try to lock it first. Okay? One of them will succeed. So the one that succeeds gets the lock. It calls the service. The other guys wait, they register for a callback, and they wait until the callback comes. When the guy that succeeds gets the value, it puts it in the cache and unlocks. The other guys get the callback, and they get the value out of the cache. Now I get 1 call to the back end instead of 3. See? And the next time we hit it, they just will all get it out of the cache the first try. All right, so that's pretty cool as a way to deal with that. Now I mentioned that you can ask for event notifications in the cache. Things like the thing was expired, it was updated, it was removed, or whatever. You can get notifications at various levels. So you can do it at the cache level, at a region level, or on a particular key if you want to. And we also added the ability to batch notifications. This was actually Xbox Live asked us for this because they were sending around, like they need to do 1 million notifications a second. Okay, literally. I mean, they have unbelievable loads. And so they, 1 call on 1 million, they're not going to hit 1 million, okay? They need to have batched notifications. So we have that as a possibility as well. Now, here's how the notifications work to really make it scalable. in each cache, you have a log. It's just like a database would do. You have kind of a transaction log, and they're ordered by sequence. And so when I register for a notification, I pick the key that I want, and then the client goes off and finds the partition and says, okay, I see where that key is, and it pulls the node. So the first time it says, I need all the changes for this key. And the cache 3 will respond and send me back a list in order of the last sequence number. All right, so it gives me those notifications. When the message comes back to the client, we store the last one. So we say, okay, last time we got up through sequence 19, and we call the delegate. Right? Then the next time we need to get notifications, we say, anything new since number 19? So it doesn't have to send me the whole list again. It only sends me what's happened since then. Right? So in our lab test, this actually scales really well in terms of managing notifications. So now, new possibilities. I'm just going to mention one because I've already, we were talking earlier. I said, how long do I have? They said, it's the last session of the day. Go as long as you want. I said, all right. All right, so I was talking to some guys who build this really cool smart client app for hospitals and doctors and clinics and things, and it's a really nice app. And I don't know about you, when I go to my doctor, I look at the app they use and I go, you guys are lame. They have something that looked like it was written in 1997, and it just looks terrible. But the one I saw was really cool, nice WPF app. And so they put it in hospitals, and the doctors love it, the nurses love it. My wife is a nurse. She hates the one that her hospital uses, but this one is really great. Everybody loved it in the hospital. And then they said, we could expand our business. Let's put this out in the clinics. So they found these little remote towns with little clinics and put them on the WAN. And then they found that people said, your app stinks. It's so slow. And the problem was, of course, it wasn't really the app. It was that they had this very thin pipe. When they were at the hospital, they had the big fat pipe to the data center. It was right there, and they were real happy with it. But this thing was very data-intensive app, a lot of database access over the WAN. The performance was really not up to speed. So we were contemplating, well, how can we help with this? Could App Fabric Cache help with this? And this and one of my other favorite things in .NET 4, which is Windows Workflow, what we did is, at least we talked about it. They didn't actually do it yet. We do this on the board. How about that? Okay. So we said, what if at night, when the database utilization is low, we just have a workflow that wakes up and says, who's coming to the clinic tomorrow? Because we know people got appointments. We know who they are. We know who's coming, right? So the workflow goes off and reads from the database all the medical records and loads them in the cache. And then the next day when the doctor fires up the app, bam, it's really fast. It feels really good, just like it does at the hospital. Now, you've got to be careful, because what could happen is, like in the morning, somebody calls and says, oh, by the way, remember that Johnny's allergic to penicillin? And then it's not in the cache, so, bad things could happen, right? I'm just saying, be careful, but it's a potential solution, right? So you have to think through the ramifications. But this idea of prefetch, this is just one example, but you can imagine other examples where if you can anticipate what someone might need before they need it, and you have if your database isn't so busy that it can't supply it, maybe you could preload things into the cache, and then when they get the page access, it's very fast, right? So that's just one possibility. One other thing I mentioned about those using the cache to prevent multiple web service calls. This is a true story. I was dealing with a big bank down in Australia, and like a lot of banks, all of their main account data is on a big mainframe. And they have a contract with IBM to run their big mainframe. And they pay based on utilization. So however many CPU minutes, that's what they pay. And so they built a composite app for tellers, and they put this app all over, and it was the same kind of thing where you have little parts that you assemble. And they had the same exact problem as I mentioned earlier, that many of these parts made the same calls to the back end, only this cost them real money. Because now they're paying for CPU minutes on the mainframe. Now this was a few years ago before App Fabric Cache, but what they did was they introduced a cache layer in the client to mediate these requests much the same way, And they just said, look, we're going to cache the results of this for 30 seconds just to eliminate duplicates. And they found that saved them, they told me, $100,000 a month in reduced calls to the back end. Whew, caching can save you some cash, right? That's pretty cool. All right, so, all right, what to do next? If you think, I want to check this out, I want to try it and find out what to do, okay. Like I said, we just released beta 2. Now, there's 2 ways to install this. You can go search on the web, and you can get the MSI installer and run the MSI and run through the whole configure thing. That's really great if you're setting it up on a server. But if you just want to set it up on a development environment like your workstations, you can try it out, see if it works for you. I recommend you look at the web platform installer. This is the coolest thing that Microsoft's come out with in a long time. And so fire up the web platform installer, and when you do, you'll look at it, you'll go like, App Fabric cache, App Fabric. Where's App Fabric? I don't see App Fabric. You won't see it, because this is one of the bad things about this, is that they said, well, we think that should be in the Enterprise tab. And you say, what Enterprise tab? So there's an Options button down there. You have to click that, okay? Then there's a thing where you say Enterprise. You click that, and then you come back, and now there's an Enterprise tab, okay? So look, people go crazy with this, and they write me emails like, I'm trying to install, I can't find the thing. Okay, there it is. All right. So, and then if you click in there, you'll find in the application server thing, there's only one thing in that group, which is App Fabric for right now. So, all right. So one other thing, I do a show on Channel 9 called Endpoint TV, and if you're saying like, well, our IT guys are pretty sensitive about servers. They want to know, what does this thing do to your server when you install it, which I totally understand. I did a whole show with Byron Tardif there, who's the PM who did all the setup. And so it's a long show. It runs about 45 minutes, but we talked through all of, ever look at like a setup and you see all these wizards and all these little buttons and checkboxes, and you're like, what does that one do? I don't know. Don't touch it. Just next, So we actually talked through what all of the buttons and all of the checkboxes mean and what they do and what impact it has on your installation. So if you want to run through the MSI setup and see how it works, he will explain all of that. The great thing about the web platform installer, there's no wizard. It just like run, it installs it, it sets everything up, and it creates all the databases you need. It sets up all the configuration. It does the whole thing, okay? And then you're done. So like I said, for a developer workstation, web platform installer is a great idea. It's not a great idea for a server, because the way you set up your server would be entirely different, okay? And we do have a more complicated setup that's for installing on a web farm, and we're going to make a video about that, because right now we just have a document. We'll make a video too. So there's also an App Fabric Center on MSDN, so you can go there and get more information about App Fabric and videos and tutorials and things like that if you're interested. Okay. Now we are ready for questions, if we have time. I don't even know what time it is. Anybody got questions? Okay, yeah, if you want, come to the microphone so that the world will see the wisdom in your question. Yes?
What's the cost of removing a server from the cluster, the cache cluster?
Okay, the cost of removing a server. I don't know that, at least I personally haven't analyzed this in terms of hard numbers, but when you take a server off the cluster, it has to rebalance all the keys that it has. So it's going to be, all of the servers are continuously talking to each other. So, when it says like, I'm going down, a flurry of activity happens as the servers start talking to each other and redoing things. And I guess it's going to depend on how much data it has and if you have high availability or not and things like that.
Let me clarify. So I've got a bunch of web servers.
Yeah.
And they're set up to scale automatically depending on load.
Right.
And I'm thinking about installing the cache application on the web server, since their memory usage is really low. It's just CPU.
Okay. Right.
And so is that a good idea or a bad idea?
We usually recommend that the cache be on a different machine. It's more ideal if it's on a different machine. It certainly would work on if you couldn't do the different machine, then just do it on the web server. It would work, but it's not the recommended way.
Thank you.
Over here.
Yes. Our application on a web farm currently uses the web's cache, and periodically we have to clear the cache. Perhaps something's going on sale or a set of items. Database has been reloaded, so the cache we want to make sure is fresh. And
Yeah.
you haven't talked about clearing cache at all, but you did mention using versioning, which I hadn't thought about that, using a version number in the cache name.
Well, so one of the interesting things, the new possibilities I didn't show on a slide, but it's a very interesting possibility, is because of the fact that this cache is shared, you can have back-end processes that deal with it, and the front end can just merely go on its way, right? So if I have a case like where, hey, we just revised the whole catalog, we need to dump all the catalog things and update them with the new one, I can have a back-end service connect to the cache and just start doing that, right? And then I don't have to try to add code to my web app to do those sorts of things.
Is that using the PowerShell or their API calls?
You would just use the same client API that the front end uses, you know, start getting keys, removing keys, or updating items, or whatever.
Use dependencies. And also there was, because it was a farm, we had to use a web service to tell each web server to clear its cache.
Yeah.
This sounds like a good solution.
Yeah, it's very cool. Yes?
So you mentioned all the communication is over WCF. Does that mean the things that the entities that you're going to cache, do they have to be serializable and marked with
absolutely.
attributes and
Yeah, it's no different than the system web cache. I mean, anything you want to put in the cache, it has to be serializable.
Okay, so do you have any recommendations, or I guess that's the standard, like how do you avoid sort of polluting your domain entities with all the WCF markup stuff, right?
So, okay, so the WCF, just so that you know what you were saying, WCF has, there's attributes that you can use to influence the serialization of the data contract serializer, right? You put, data contract and data member and all that. And prior to WCF 3.5 SP1, those were required, but they're not required anymore. They're optional. But for AppFabric Cache, it doesn't even require that because the serialization that happens is it just has to be marked serializable. The type has to be serializable because you're just calling a local API when you call the data, the puts and all that, and it serializes it. Then AppFabric Cache does all the WCF calls under the covers. But you don't have to really, as long as your object is marked serializable, you don't have to add data contract, data member.
Does that take all the public and the private fields, or is it just like XML serializer where it's public? It's the when you put serializable attribute on it, I think it does everything.
Okay. Yeah. That's what I'm just kind of on the spot, but you made me feel better. You shook my, yeah, okay. All right.
Trust that guy.
Yeah. Hopefully you're right. Okay, over here.
You said the servers rely on .NET 4, and I was curious if there's any particular niftiness in there that they're leveraging.
Any whatness?
Particular niftiness in .NET
Niftiness?
4. Yeah.
Well, of course, .NET 4 is very nifty. It's just an issue of that's the release we're on, And like product teams we always try to deliver into the current release train, So that is the release we're on. We did build the client libraries specifically for .NET 3.5 SP1 because we wanted to support that level of platform. But there may be things. Who knows? .NET 4 is obviously more nifty than 3.5 SP1. So, all right, yeah.
So when you're thinking about Silverlight for support, out-of-browser support, or even in-browser support, having a client cache there that you could leverage like you could do in a WPF scenario or anything like that?
Yeah, that's certainly in consideration. So, client libraries for Silverlight, because we do see a lot of people who are planning on essentially building a client app that's Silverlight for out-of-browser, full trust, all that. So that's certainly under consideration.
Okay.
Yeah. Over here.
So I think you mentioned it, but do you plan to include support for read-through caching?
Yeah, so they're sort of in the great beyond of things that the team would like to do. There was some thought of, wouldn't it be cool is if we, at the data architect level, like when we're actually designing our data in our database and stuff, when we look at tables in the database and we say, here's a table, this is resource data, or this is reference data, this is totally cacheable, and if we could somehow attribute it so we could say, at the data level, this is safe to cache for 5 minutes. And then any app that uses it, the cache tier would automatically cache it that way, or things like that, are things that are certainly under consideration, and then, kind of doing the right behinds and read-throughs and all of that, but it's way out in the future. So, yeah.
Because things aren't scoped to process anymore, if you have multiple applications, how do you handle the collision of keys?
Right. So what happens is all the servers are communicating with each other constantly to try to avoid those kind of conditions, right? And so basically, they will throw exceptions when they can detect it. Honestly, I don't remember what the explicit behavior is when they can't, when it's too late.
If you and I are both writing an app and it's stored on the same app, it's caching on the same app fabric, and we
Yeah.
put our key of current user or whatever.
Right,
it's
right.
Really generic. I mean, do you have to manage that?
Well, so if you try to write a key that exists,
Right.
it depends on the API that you use, okay, as to the result. So if you use the one where you try to where you lock it and you try to update, then you would get an exception.
But they're different pieces of data, right?
Right. I get what you're saying. Like, yeah, if you use a key called current user and this app does current user, it just overwrote that current user, right? So, yeah, you have to be a little careful about the keys, and we don't try to do anything clever to manage the keys. Unless you use like the more sophisticated APIs, then that include the version things, then you can get a little protection from that. But yeah, you have to be careful about.
So you would want to get your key names to be scoped. That it might be like a.
Yeah, you want to use better keys than A, B, things like that. Yeah.
Can keys be in more than one region?
I'm not sure, actually. Yeah, I don't know. I haven't tried it.
Okay, can regions be nested?
No.
Okay.
No. Okay.
Can you elaborate a little bit, just to make sure I understand, what are the real advantages of this beyond over sticky sessions? If you already have sticky sessions implemented well, they're not that hard to set up. What would be the impetus to move to something like this?
Well, so, most people who really look at web performance and stuff say sticky sessions are an okay convenience, and they take you up to a certain point, but then they eventually limit the scalability of the farm. They kind of, the load balances unevenly. And again, it's going to depend on the nature of the site as to how long the sessions stick around and how many hits and so forth. But for some sites, maybe it's not that big of a deal. I mean, there's no hard and fast answer for this. I guess you would just have to say, like, this is where we get back to the simple versus the scalable. If you're on the sticky sessions and it's working okay for you, and you say like, hey, it's working okay, why knock ourselves out to put something in place that might not do any better? Don't do it. We try to make it easy to put this in place with the session state provider, so that if you wanted to try it, you can flip the bit, go to the session state provider and try it, and see what you get. So, yeah, over here.
What's
Hey.
the realistic number of machines that can participate in a cache cluster?
Yeah. So when you set up the cluster, it asks you, what do you think the size of the cluster is going to be? Like, there's 0 to 5 machines. There's what is the next size? There's like 6 to 20, and then there's greater than 20. Okay, almost nobody's going to make greater than 20, except for maybe like Xbox Live or somebody like that, right? And there's probably a theoretical upper limit where it begins to bog down. Now, they did actually design the fabric itself, because it's designed from Windows Azure, is designed so that the machines only have to talk to the next one in the cluster, not all of them. So you don't get the kind of this explosion of connections. So it scales up pretty well. But realistically, most of the customers have done it with 5 or less servers. Yeah. Over here.
So there was a concept of default when you created the factory object, right?
Uh-huh.
So are the keys unique to, let's say, default for some other name, or are they Could they collide, even if, let's say, you have one that's called default, and you have another application that wanted to say...
Yeah, so the keys are within the cache. So I have cache 1, cache 2, cache 3. I can name caches, right? And they don't have to be unique across caches. Because, you might have the same cache farm serving, 5 different web apps written by 5 different teams and things like that. You don't have to try to coordinate the keys across caches. That would be a nightmare.
So they can use that to solve that current user example?
So within the app, you would, when you create a key, if you just stored current user, like you log in and current user stores your name, and then I log in, current user stores my name, then we're in a problem, right? So when we have something that's like per user state, you'd probably want to put a user identifier as part of the key. So when you're accessing the state for me, you get different state than when you access the state for you. Yeah. Over here.
So I think you just mentioned that all the communication happens just through one of the servers. What happens if that server goes down?
So the servers, there's code in the fabric layer to detect when processes or servers die. And if a process dies, it can very quickly detect that process died and reconfigure itself. So it knows, it doesn't, I'm simplifying it when I say they only have to talk to either one. I mean, it knows about others, and so it goes, oh, that one's dead, I'm going to go to this one. I mean, it knows about them, it just doesn't have to talk to them all the time. But when a server dies, it has to wait for TCP to time out, which can take, a number of seconds. So its recovery depends on the nature of the death it's dealing with, right? And then it recovers, either that thing comes back online and recovers and rejoins the cluster at some point. Or in the meantime, it reconfigures itself around the dead node.
But will it, I guess what I'm asking is the client configuration was only pointing to one of the servers.
Oh, yeah, okay. So if in the config, the client was pointing to one of the servers, the client knows that's its entry point into the cluster, right? When the client processes up, it has a routing table where it knows, so it'll learn about the rest of the cluster through the routing table. So if the main one died, the one that was pointing it died, it would still be okay. But if the process starts up and the one that the config is pointing to is dead, then you're going to have an issue. So that is a valid concern. Okay, over here.
Hi. If my application is not running in a web farm,
yeah.
Are there any advantages in using this new API as opposed to system web cache?
If your application, is it a web application?
Yes.
Oh, okay, a web app running.
In preparation to moving to a web farm. Are there any advantages?
So it's running on a single server today, and you're thinking down the road it's going to move to a farm. Well, look, you could say, it just goes very simple. Use session state, and then when you move to the farm, plug in the cache session state provider for App Fabric cache, and you wouldn't have to change your code at all. The other option would be, like I showed you earlier, the slide where I had the code from System Web Cache. You could start with System Web Cache, and then later when you want to go to App Fabric cache, you just have to add a little bit of code to create the factory and do up the cache. You could wrap all that inside some class that conceals it all everywhere else, so then you only have to change it in one place. You could do that kind of thing. But if it's only running on one machine, is there any big advantage? Not really. Not at this point, yeah. Yeah?
Are there any plans to have data services support caching?
Yeah. So one of the interesting questions, in fact, I was looking at this for just very recently. I was asking, so data services, formerly known as ADO.NET Data Services, now known as WCF Data Services, gives you a way where you can take an entity framework model, expose it as a RESTful service, and it's just kind of all automagical. It just happens. And it's actually very cool because I'll be talking about this on my session tomorrow about RESTful services. You can create these expressions, and they get sent across the wire and invoked over here. But there's like, yeah, but where do I put my cache in here? So I'm not super great on entity framework and data services, but I've been talking to the team about it, and certainly it's something they're looking at in future release is, and this may be one of the ways in which that kind of policy-driven caching emerges, is that maybe the first way is you might describe in your model the cache properties you want, and then the model would just leverage the cache. That would be the ideal way, but right now it's not an easy way. Yeah?
You may have mentioned this earlier, but the configuration store where it's either a database or an XML file on a share, can that change after the services have started, and are they monitoring that actively to potentially reconfigure?
Right. So the way it works, in fact, you can actually see it. If you use the XML provider and use a PowerShell commandlet to change something about the config, I almost showed this. I forgot to show it. But in Visual Studio, like you use the commandlet and you go back to Visual Studio, it'll say the XML file changed, and it'll reload, and so when the shared thing changes, the nodes detect the config changed, and they kind of go off and redo their thing. Now, if you wanted to change from XML store to SQL store, that's a different kind of change. It's not a commandlet to do that. So what you have to do is you have to go around to each of the nodes of AppFabric Cache, and the change happens at the machine config level, where you register the config store provider. And yes, you'd have to restart the services to get it to pick up that change. It would be the kind of change that would be a little unusual, especially in an on-production environment. But
right. To the guy's question earlier about like scaling up, dynamically adding app servers. If you wanted to dynamically add cache servers, you would do that through PowerShell.
Well, when you add a new server, you if it joins the cluster, what you do is you say, you talk to this server. You're part of its cluster, so you're gonna look at this config store, whatever that's database or shared XML, and so when it comes up, it's going to read that config store, and it's going to learn about the cluster, and it introduces itself, says like, hey guys, I'm here, I'm ready to work, and they start incorporating it. So, okay, we're totally out of time. I know you have some more questions, so you guys come on up here. Thanks a lot.